Hey guys, welcome to 3.1 Extrema on an interval, part 3. So let me go ahead and finish off the rest of the problems of this lesson. So let me go ahead and erase all this. And we'll go ahead and start with letter B. So before we continue with letter B, let's take a look at the steps that we did in example number 1. Or let's just take a look at the steps, period. Step 1, we need to find the f prime and then find the critical numbers. Step 2, we evaluate the critical number using an x and y table and also the endpoints. And the final step says determine which of these values is the least and the greatest. So let's go ahead and do part B. Part B, we need to find the derivative. Oh, and that's it. Okay, good. So that's my derivative. And then what we do is we take the derivative and we set it equal to 0. And then what we want to do is we want to solve. So let's go ahead and factor 6x squared, and that'll leave me with a 3 minus 4x. Let me just check to make sure that's true. Okay, yes. Alright, so when I factor 6x squared, I have now a product that equals 0, and that means I can separate and solve. Which means I'm going to have x equals 0 and x is equal to 3 over 4. So I have two critical numbers. These are my critical numbers. Including my endpoints, I have a total of 4 candidates. And we're going to go ahead and plug in all these numbers into our x and y table. So let's go ahead and begin with -1, 0, 3/4, and 2. So plugging in -1 into my original function, because we want to find the minimums and maximums of f. So we got to plug them back into our original equation. So we have 6 to the -3rd minus 6 times -1 to the 4th plus 5. So that will give me -6 minus 6 plus 5, which is 12 plus 5, -7. Now for 0 it's simple. If I plug in 0 to my x's, I get 5. Now let's go ahead and do the easy one. Let's go ahead and do 2. 2 cubed minus 6 times 2 to the 4th plus 5. 6 times 8 minus 6 times 16 plus 5, and that is 48 minus 96 plus 5. Again, this is -48 plus 5, which is -43. Okay, so I have three values already defined. So far I have -43 to be the least. Now let me go ahead and compute the 3/4. And that gives me 721 1 over 128, which is roughly 5.632, and so on. Okay, so now I know I cheated there, but I mean, because I can, I'm the teacher. But anyways, you guys can check that and you guys will be able to get 5.6. And what is my maximum? My maximum was it was very close. My maximum is actually -3/4 for the x and 5.6 for the y, and my minimum was 2 and -43. So let's go ahead and write that down. So it's 3/4, comma, 5 well, let's not use that. Let's use the exact value. That's my max. My min is 2 negative 43 minimum. Next example, letter C. Letter C, we have a function that has a rational power, so let's go ahead and take the derivative. That is 3 times 2/3 x to the negative 1/3 minus 2. And then what we do is we set that equal to 0. So first of all, you can cancel out the 3's. So you get 2 over x to the 1/3 minus 2 is equal to 0, which is the same thing as 2 over the cube root of x minus 2 is equal to 0. So what we want to do is we want to solve. Well, before we start moving things around to the other side, why don't we go ahead and find a common denominator. So it's going to be 2 over cube root of x minus 2 times the cube root of x all over the cube root of x equals 0. Okay, so now that we have the same denominators, we can go ahead and combine the numerators. 2 minus 2 cube root of x over cube root of x is equal to 0. Now, what does it mean to be a critical number? If I go back to the definition first, f prime of c is equal to 0. In other words, when the derivative is 0, I have a critical number, and when the derivative is undefined. Well, if I look at this fraction, let's take a look at the undefined part first. What would make this fraction undefined? Well, if this whole thing in the bottom was 0, it would make that derivative undefined because that is my derivative. So set it equal to 0 and solve. X is 0. Critical number. Now, what would make this fraction equal to 0? Well, if the top of the fraction was 0, then the whole fraction is 0. So set the top equal to 0. And that is 2 cube root of x is equal to 2, cube root of x is equal to 1, and x is 1, which is another critical number. So I have a total of 4 candidates. So -1, 0, 1, and 8. And I go ahead and plug those in. 3 to the negative 1, 3 times -1 to the 2/3 minus 2 times -1 plus 1, and well, this is going to be easy, right? If you plug in 0, you get just 1. If you plug in 1, let me see, you get 3, 1 to the 2/3 minus 2 times 1 plus 1. And finally, it's 3 times 8 to the 2/3 minus 2 times 8 plus 1. Well, -1, if I take a look at -1, the top number of this power means that I'm squaring it. So -1 squared is a positive 1, and the bottom number means that I'm cube rooting it. So that's cube root of 1 is 1, so that's 3. Minus a double minus, which is a plus 2 plus 1, and that is 6. This one we already know what it is. It's a 1. Well, the next one is 3 times 1 to the power of 2/3, and that is just simply 3 minus 2 plus 1, which is 2. The last one. So let's go ahead and use the same logic that we did in the first one. The top number means to square, and the bottom number means to cube root. But let me go ahead and do it the opposite direction. Let me go ahead and cube root first the 8 and then square it. So if I cube root the 8 first, the cube root of 8 is 2. 2 squared is 4 times 3 is 12 minus 16 plus 1, which is -4 plus 1, which is -3. So this is my minimum and this is my maximum. one last problem to end this off. I need to erase all of this stuff. This problem won't take long. So we have a trig function now on the closed interval from 0 to 2 pi. So it's f prime is equal to sine squared of x. Okay, so f prime, what's the derivative of sine squared? Power rule, drop the 2, keep the inside, and then take the derivative of the inside and multiply it to the outside, which is cosine. Plus, the derivative of cosine is negative sine. Now, I set that equal to 0. Well, what do I have in common? I have sine in common. So I'm going to factor out sine. So I get 2 cosine x minus 1 is equal to 0. Again, I have a product. So separate and solve. Sine x is equal to 0 and 2 cosine x minus 1 is equal to 0, which is the same thing as the cosine of x is a positive half. Now, we're dealing with a closed interval from 0 to 2 pi. What angle of sine will give me 0 from 0 to 2 pi? If you know your unit circle very well, sine of pi over 2 gives me 0, and sine of 3 pi over 2 gives me 0. Now let's go ahead and take a look at the cosine of a half. Same thing. I'm dealing with the interval from negative 2 to pi. I'm sorry, from 0 to pi, 0 to 2 pi. What angle of cosine gives me a positive half? And if you know your unit circle very well, cosine of pi over 3 gives you a positive half, and also the 5 pi over 3 gives you a positive half. So I have a total of 6 numbers to test. I have 0. Next is pi over 3, then pi over 2, then 3 pi over 2, 5 pi over 3, and 2 pi. I'm going in order. If you know your unit circle, this is the order of the angles that I'm given. So I have a total of 6. 1, 2, 3, 4, 5, 6. Yes, okay. Let's go ahead and plug in all these numbers to our original. Sine of 0 is 0 squared, which is 0, plus the cosine of 0, which is 1. That's 1. Next is pi over 3. Sine of pi over 3 is square root of 3 over 2 squared is 3 over 4, plus the cosine of pi over 3, which is a half, which is the same thing as 2 over 4, and that is 5 over 4. Pi over 2. Sine of pi over 2 is 1, squared is 1, cosine of pi over 2 is 0, so that's 1. 3 pi over 2. The sine of 3 pi over 2 is 0, squared is 0, plus the cosine of, I'm sorry, no, not 0. Sine of 3 pi over 2 is negative 1, squared is positive 1, plus the cosine of 3 pi over 2, which is 0, and that's 1 again. 5 pi over 3. The sine of 5 pi over 3 is the negative square root of 3 over 2 squared, which becomes a positive 3 over 4, plus the cosine of 5 pi over 3, which is a half, which is the same thing as 2 over 4, which is 5 over 4. And the cosine of 2 pi, which is the same thing as 0, well, that is 1. So, what are my maximums and what are my minimums? I have a maximum at 5/4. So at x equals pi over 3 and 5 pi over 3, I have a maximum. And okay, so I made a big mistake. I need to fix this. I just realized that the sine of pi over 2 and the sine of 3 pi over 2 is not 0. It's pi, which means that these guys don't count. Quick fix, don't get mad at me. If I plug in pi, sine of pi is 0 squared, and then cosine of pi is -1. So that means that the yellow, these guys are my max, and this is my min. Okay, so sorry about the last problem. So I went too fast and I figured out what my mistake was, and there it is.